In this video, we will explore what atoms are and how they come together to form a variety of different substances. Everything in the universe is made up of tiny particles called atoms. Three types of subatomic particles make up the atom. A tiny central nucleus consists of protons and neutrons, and it is orbited by electrons. There are many different types of atoms found on Earth. Elements are substances which are made up of only one type of atom, so this means the number of atoms and elements are the same. Elements vary in their physical and chemical properties. There are some elements which are non-metal gases at room temperature, such as hydrogen, and some which are solid metals at room temperature, such as magnesium. All elements have names and are also represented by symbols, such as O for oxygen and Li for lithium. This means that although the names of the elements may change, the symbols will always stay the same. These symbols are used to represent atoms of the elements in the periodic table. Elements are arranged in the periodic table according to their properties. They are arranged in vertical columns called groups, with the elements in a group having similar chemical properties. The periodic table features metal elements and non-metal elements. Generally, metals are on the left and non-metals are on the right. The separation produces a characteristic staggered line. Some elements close to the line are called metalloids. This is because they share some metallic properties and some non-metallic properties. Atoms of different elements can bond together, forming compounds. An example of a compound is carbon dioxide. A carbon dioxide molecule is one atom of carbon bonded to two atoms of oxygen. We can use the type and number of atoms to write a formula for the compound. This means carbon dioxide becomes CO2. Some compounds consist of only two types of atoms, such as water, however most are made up of more than two, such as sulfuric acid. The different types of atoms and compounds are held together by chemical bonds. Understanding chemical equations is a vital part of studying chemistry. We are now going to look at the importance of chemical equations and how to form them. Chemical equations are used to show the starting substances and the substances made in a chemical reaction. The starting substances are called the reactants and the substances made are called the products. A chemical equation may be a word or a symbol equation. Word equations obviously use the names of the reactants and products, whereas symbol equations use the chemical symbols. For example, copper 1 oxide will react with carbon monoxide to form copper and carbon dioxide. In symbol form, this is CuO plus CO to form Cu plus CO2. Because symbol equations show the number of atoms of each element involved, the equation needs to balance. This means that the number of each type of atom on both sides of the equation needs to be equal. In our reaction, the symbol equation is already balanced. The law of conservation of mass is the reason why a symbol equation needs to be balanced. The law states that the combined mass of the reactants is equal to the combined mass of the product in a reaction, because atoms cannot be created or destroyed during the reaction. When checking if an equation is balanced, you simply count the number of each type of atom on both sides of the equation, and if they are equal, then the equation is balanced. Let's look at an example together. So CH4 plus O2 forms CO2 plus H2O. You will see that the equation needs balancing. Firstly, we can add a big 2 in front of the H2O to represent 2 molecules of water. This means there are now 4 atoms of hydrogen on both sides of the equation, so the hydrogen atoms are now balanced. This leaves you with 2 oxygen atoms in the reactants and 4 in the products. To balance the oxygen atoms, we need to add a big 2 in front of the O2 to represent 2 molecules of oxygen. If you count the atoms again, you can see there are equal numbers of each type of atom on both sides of the equation. When balancing an equation, you must remember that you cannot add or remove small numbers which follow a symbol, because these numbers are to show how many atoms are actually in the compound. When balancing, we can only add big numbers in front of the symbols. These big numbers multiply all the atoms in the following compound. A balanced symbol equation must also include state symbols. These show the state of each reactant and product. The states are S for solid, L for liquid, G for gas, or AQ for aqueous solution. This is dissolved in water. For the combustion of methane, the states are as follows. If you are sitting higher tier, you need to be able to write and balance ionic and half equations. Ionic equations involve ions, which is a particle with a charge. Ionic equations are produced from symbol equations and only involve the particles which change state. These ions only exist in aqueous solution. To derive an ionic equation, you first need to write the symbol equation for the reaction. You must include state symbols. For example, let's use the following equation. The ions in this equation are Ag+, NO3-, Na+, and Cl-. you remove the ions which appear on both sides of the equation, in this case Na plus and NO3-, and you get the Ionic equation. Just like normal symbol equations, Ionic equations have to balance too. Half equations show a particle such as an atom or a molecule gaining or losing electrons. If an atom is gaining electrons, the half equation will have the reactants as the atom and the electrons, with the ion as the product. If an atom is losing electrons, the half equation will have the atom as the reactant, with the ion and electrons as the products. Half equations are written with chemical symbols, include state symbols, and must be balanced. An example of a half equation is this equation.